Good evening, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the third lesson on geometric sequences, and in this lesson I'm going to be talking about sigma notation. Incidentally, this is also the 100th episode that I filmed for this channel, so I've brought my bat to acknowledge the century. Thank you very much. Right. All joking aside, sigma notation. So we have a very simply written example here. Evaluate this. R equals 1 to 8, 5 to the power of r, and this Greek letter here, which we've met before, it's the Greek letter sigma, but for this purpose it means the sum. Now r equals 1 is where you start. 8 is the number of terms you go up to, so for the purpose of this is where you stop. And this bit here, 5 to the power of r, that is the rule for the sequence. And what I always suggest to students to do just for this is to write out a few terms of the series to get an idea of what it is, how it's behaving, and they tend to be quite straightforward to work out. So if the rule is 5 to the power of r and we start with 1, the first term is going to be 5 to the power of 1, which is just 5. The next term would be when r is 2, so 5 to the power of r is going to be 5 squared, which is 25. And you can probably see already what a and r are going to be, but I'll carry on to the third term, which would be 5 cubed, 125. And what you've probably spotted by now is that each time you move one term in the sequence, you're multiplying by 5, and the first term is 5, so therefore a is 5 and r is 5. Now, because this is asking for a sum of the first 8 terms, we would be using the sum to n formula, which is a times by 1 minus r to the n over 1 minus r. We're going to do the sum to 8 terms with a is 5 and r is 5. So sum to 8 is 5 multiplied by 1 minus 5 to the power of 8 all over 1 minus 5. Now remember what I said, it's worth working out this value inside the brackets separately so that you don't make a mistake in your calculator, typing into the calculator. So we get negative 390,624, and that is all over negative 4, so 1 minus 5. So all I have to do is to work that out now, multiply it by 5 and divide it by negative 4, and it comes out as 488,280. So the sum of the first 8 terms. So there we go. If you see this notation sigma, it means you're doing a sum. You're told the term to start from, the term to stop, and you're told the rule. But because we're using a sum and we've identified that it's a geometric sequence, this is the formula we're using for sum to n terms. And there's the answer. Job done.